2 from the 2016 paper. Question 2a, we asked to find the fixed points of this complex iterative map. We want to find the fixed points of periods 1 and 2 and determine the stability of fixed points of period 1. So the fixed points of period 1 satisfy the equation Zn plus 1 equals Zn. I might as well call it Z. So we've got to solve this equation, which we can do in MATLAB. We have to define Z to be symbolic. And then we want to solve this equation. So we use the solve command in MATLAB. So it's Z squared minus Z plus 2 plus 5 times I is 0. That gives the third form. If we want the variable precision answer, and we'll give it to 5 significant figures, then we can see here are the two fixed points of period 1, which we label Z11 and Z12. To determine the stability of these fixed points, we look at the derivative, so df by dz. If we differentiate f, then we just get 2z. And then we take the modulus for each of these fixed points. So the modulus of 2zz11, again, you can easily find this with MATLAB. You can see that number is bigger than 1, and the modulus of 2z12 is also bigger than 1. So both of these fixed points are unstable. To find the fixed points of period 2, we want to solve Zn plus 2 equals Zn equals Z, which gives us this quartic equation. So in MATLAB again, we want to solve a quartic equation. So we simply say solve, and we've got this quartic equation, which is Z squared plus 2 plus 5 times I, and then we square that, and then we add 2 plus 5 times I, and then we must remember to subtract Z. This is where most students make a mistake. They forget to subtract the Z when you're solving this equation, so you have to subtract Z. So we solve that equation. Again, the answers are in third form, so we can just take the variable precision answer to 5 significant figures. Now in the exam you will know if this is correct or not, because your two fixed points of period 1, which are here, and you can see they are the first 2 points here, they are repeated. Okay, but we discount these two fixed points of period 1. So therefore, we have these two fixed points of period 2. So we have 2 fixed points of period 2. For part B, we have this map defined by xn plus 1 equals f of xn. The first part of the question, we have to plot the functions, which is easy to do. So let me just zoom in on this picture and to show you this. And we want to find the fixed points which remain bounded after 1 and 2 iterations. So using graph paper, pencil and rule, we can see here we've drawn the line minus 6x plus 2 is this first branch here. Then we've got the 6x minus 4 is this branch here for x between 1/2 and 1. And the red line is the line y equals x. And we want to know which points remain bounded in this region here, 0 to 1. So you can quite clearly see I've labelled the regions here in green. So if a point starts within this green region here, we go up to the curve, across the diagonal, and that remains in 0, 1. And you can see we go from 1/6 to 2/6. If we start and iterate to the left of 1/6, say here, we go up to the curve, across the diagonal, and now you can see we're outside 0, 1. Similarly, if we start outside 2/6, so we start to the right of 2/6, we go up or down. In this case, we go down to the diagonal. We go left or right to the, we go down to the curve, and then we go across the diagonal, which will be over here. And again, that's outside 0, 1. But these points in green, we go up to the curve, across the diagonal, they remain in 0, 1. Similarly, these points here, we go up to the curve, across the diagonal, these points also remain in 0, 1. So therefore, our first bounding region for fixed points of period 1 is 1/6 to 2/6 and 4/6 to 5/6. Now to find the points that remain after 2 iterations, what we do is we take these regions, the 1/6 to 2/6 and the 4/6 to 5/6, and we put them on this y-axis. And then we read across here, and the corresponding x values will give us these values here, which are the bounding regions after 2 iterations. So for example, if we look at this upper green region here for the first branch here, when we read across these for the green region, that will map into the x region. X goes from 7/36 up to x goes to 8/36. So this point here corresponds to this first bounding region. And then similarly, if you read across to this branch and this branch here, and we go across here, you'll see that we get 4 regions. And you can check these yourselves later. Okay, and that concludes the answers to part 2.